Okay, hello everybody. You guys had lots of Kognity questions. In fact, you asked you guys asked me to almost do every single problem. It was 1, 2, 3, 4, 5, 6, 7, 8 of them out of 10. um, so I will do half of them. I will do 5 of them. Half as in half of all of the questions. Okay, so we are doing 5 problems. The problems that you guys asked the most for were 2, 3, 10, 6, and 9. So that is what we're doing right now. So we're going to start with number 10. Okay, so number 10 said, or I'm sorry, why am I saying number 10? Number 2, we're not doing number 10. We're doing actually, we are doing number 10. Never mind. I'm sorry. We're doing number 2 now. Okay, so it says in a geometric sequence, the sum of the first n terms is 5 to the n minus 2 to the n over 5 to the n. So that's an ugly n, is just telling us that this particular geometric sequence has a little fancy way we can rewrite our summation that's not necessarily the formula that they give us in our formula book. That will also always work. This is just like a super special little function that has a fancy little thing that you can do. Okay. So it wants us to find the sum of all terms, so infinitely many. So our goal is to find S of infinity. Okay, we know a formula for S of infinity. The formula for S of infinity is U1 over 1 minus R. Okay, so in order to find this, we need to know what U1 is, and we need to know what R, oh my goodness, I wish I had whiteout, is. Okay, we need to know those two things. All right, so we do not know those two things, but we do know what the sum of the first n terms is. It happens to be that U1 is equal to the sum of just the first term because it's just one term there, okay? So we can figure out what U1 is, and that will give us this guy right here, okay? So we're going to have 5 to the 1 minus 2 to the 1 over 5 to the 1. 5 minus 2 is 3 over 5. This is U1, okay? We have one piece that we need. Now, a way to calculate the R that utilizes what we already have is by taking R2 and, I'm sorry, U2, and dividing it by U1, okay? This is not going to be too difficult to find. The only thing we need here is U2. We have U1, okay? So what we can do is the sum of the first two terms is just U1 plus U2, correct? We have U1, we can calculate S2, then all we have to do is solve for U2. So S2 is going to be 5 squared minus 2 squared over 5 squared. U1 was 3/5, and we don't know U2, that's what we're solving for. Now, if we simplify the left, we'll have 25 minus 4 over 25 equals 3 over 5 plus U2. 25 minus 4 is 21 over 25. Then when I subtract, well, first let's get a common denominator. That'll be really nice. We need to multiply by 5 on top and bottom. So we'll get 15 over 25 right here. When I subtract 15 from 21, I should get 6 over 25, and this should be equal to my U2. Okay, so now I've solved for U2 and U1, which is super nice because now I can take U2, which is 6 over 25, divided by U1, which is 3 over 5, and I'll have my R. So I'm going to rewrite this as 6 over 25 times 5 over 3. This is super convenient because I have lots of common factors I can cancel out. I can cancel out the 3, and this is really 3 times 2, so I'm left with 2 on top. Cancel out my 5 with the 5 that's in the 25 to get just 5 on bottom. So I have my common ratio is 2/5. This is super nice. Now I have my R. Now I have my U1. And so I can find my S of infinity by taking 3/5 and dividing it by 1 minus 2/5. This is really great because 1 minus 2/5 is just 3/5. So I get 1. And that should have been your final answer for that whole problem. Okay, so that's number 2. Number 3. I'm going to do number 3 on a separate sheet of paper because number 3 got a little long and I had to skip steps to do it on one sheet of paper. Okay, so number 3. So let me actually go to the problem so that you guys can know exactly what it said. It says the sum of the first 3 terms of a geometric sequence is 139/20. So the sum of the first 3 terms of a geometric sequence is 139/20. The sum of infinitely many terms is 50/7. If it says find the value of the common ratio of the sequence. Okay, so our goal is to figure out what R is. Okay, so what I suspect when I see something like this is that I'm so sorry. It's like 8:00 at night. I'm so tired. We need to figure out 2 different equations that have a U1 and an R in them for both of these little equations right here so that we have a system of equations and we can solve for R. So S sub 3, we are given in our formula booklet. S sub 3 is just going to be, so I know that S sub 3 is equal to 139/20. Oops, not 29. It's equal to U1 times 1 minus R to the n over 1 minus R. Now, I will say, and some of you may have come into this issue, you may have set this up with the R coming first, like R to the n minus 1 and then R minus 1, and then you don't get the same answer. Now, what I think that is due to is the fact that S sub infinity, which is 50/7, is going to be equal to U1 over 1 minus R. I think that because this infinite sum is written in terms of 1 minus R, we need to choose the 1 minus R form for our finite sum. Okay, I think that that's why the other way doesn't work. I didn't prove that that's why it doesn't work. And normally there is no difference between using the 2 different types, but we're gonna go with this for now. So we have our 2 equations. I'm gonna go ahead and scribble this out because we just want equations with U1 and R in them, okay? Oh, and I did this last time too. This n is a 3 because it's specifically the third sum. I'm sorry about that. So and this is U1. So what I would do is I would solve for U1 in each of these formulas because if you solve for U1, then you can basically eliminate it. Then you're setting each equation equal to each other. And you just have R's in them, and then you can just solve for R. So let's go ahead and solve for U1 in each of the formulas. So I'm going to multiply by 1 minus R here. This one's the more complicated one. And I'm going to have 139 times 1 minus R all over 20 equals U1 times 1 minus R cubed. Okay. Then I want to go ahead and divide by 1 minus R cubed on both sides. So that I can get U1 by itself. So now I have that 139 times 1 minus R over 20 times 1 minus R cubed is going to be equal to U1. Okay, so I'm good with that one. That was a more complicated one, so now we have less to do. Then on this one over here, I'm going to multiply by 1 minus R. Man, I really wish I hadn't written S of infinity because now it's just really ugly, where I wish I had white out. Okay, so cancel those guys out. And then you'll get that U1, I'm switching sides, sorry, is equal to 50 times 1 minus r all over 7. Okay, so now I have two equations, both equal to U1. This means I can set them equal to each other. So I'm going to have 139 over 20, oops, 1 minus r cubed equals 50. 1 minus, oh, I know what my mistake was, guys. So I'm sorry. The whole thing over here that I was telling you about where you need to pick 1 minus r cubed, that's a lie. You don't have to pick 1 minus r cubed. I just made a stupid mistake in my original work. It works out no matter what equation you choose. I apologize so much for that. Basically, when I was doing this earlier on my own, instead of keeping this as r minus 1 here, I switched it to 1 minus r on accident, and it should not have been. Oh, right here, I switched it to 1 minus r, but it should be r minus 1. And so I canceled them out, and I wasn't supposed to be able to cancel them out, so I missed a factor of -1. Anyways, if you don't understand any of that, forget what I said. Just know that you can pick whatever equation you want for the sum of the first three terms. I'm sorry. Okay, so now I do have 1 minus r on both sides, and I know that I do, so I can cancel them out. Okay, so now I end up with 139 over 20 times 1 minus r cubed equals 50 over 7. So let's just cross multiply, get this out of the denominator. So I'm going to have 139 times 7. 139 times 7 is going to be 973. 20 times 50 is going to be 1,000 times 1 minus r cubed. So I just cross multiplied. Divide both sides by 1,000.